Hi, welcome to Sigmoid Tech Talk. My name is Uttam, working with Sigmoid as a lead data engineer. In this series, I will talk about data pipeline architecture patterns, best practices, and its challenges. Moving on to introduction to data pipeline. Data pipeline is a very critical component of any data-driven organization. It enables businesses to leverage their data assets to derive meaningful insights, thus gaining the competitive advantage by number one, reducing the data processing time. For example, Spark reduces the data processing time by 100 times compared to Hadoop MapReduce processing, making it faster to gain insights. Number two, by minimizing the data errors and improving the data quality. For example, libraries like Data Cleaner and Great Data Cleaner reduce the data error and improve the quality by filtering the error rows, which could be up to 20% in some cases. Moving on to data pipeline architecture. This is general data pipeline architecture consists of mainly 5 layers. First one is data source. Could be a flat file, data from distributed systems or cloud solution providers such as Google Analytics, SAP Marketing Cloud, or Salesforce Marketing Cloud. Data could also be in unstructured or structured format. Second layer is data integration layer, responsible for extracting the data from various sources, transforming it into a unified format and loading it to a target system. For example, HVR and Click both are data integration platforms that provide a real-time data replication and use a log-based approach for this, ensuring the target system is always up to date. Third layer is data processing layer. You can call it ELT or ETL, which collects the data from different sources and loads the data to data warehouse or a data lake after transforming it into a desired format. Tools like dbt, Apache Spark, Apache Nifi can help in transforming the data. Next layer is data lake or data warehousing solutions, which generally stores the raw data, metadata, and the summary data, which is nothing but the insights built on top of raw data. Here are few widely used data warehousing solutions such as Snowflake, BigQuery, Redshift. The last layer is visualization, where we have visualization tools such as Power BI, Tableau, etc. that display the insights to business executives. These tools and components help managing the data pipelines through data cleansing, data transformation, data enrichment, and validation. Moving on to users of a data pipeline. Consider you are collecting a data through a distributed systems to your data pipeline. Broadly, there would be 3 types of users to consume the output of the data pipeline that you have built. The first one is a data scientist, to build the models that predicts user behavior. For example, which users are most likely to become customers. Second, developers, to maintain the data pipeline. For example, why the app is crashing for some users. Third, business executives, who takes the decision on the insights which are built. For example, how many users became customers last year. I will wrap up the first part of the series here. See you soon. Hope you enjoyed the first session. In this second session, I will talk about design patterns. There are various types of design patterns, namely ETL, streaming ETL, ELT, CDC, and data stream processing. Now let's talk about ETL. This is a most popular design pattern for loading the data into data warehouses or lakes. It involves the extraction, then the transformation, and then the loading of the data from one location to another location. Most ETL processes use batch processing, which introduces latency to the operations. ETL works most data integration processes where the data sources undergo integration at different times. As I said, when should we use ETL processes? When there is a need to integrate the data from multiple sources for analysis. Now let's move on to streaming ETL. This pattern is identical to standard ETL pattern, but where data stores act as an origin for traditional ETL, data streams become the origin in this case. The process involves parsing and filtering, followed by transformation and loading into a data lake. Streaming ETL utilizes a streaming data processing tools like Apache Kafka or StreamSets data collector engine to perform the complex ETL processes. When should we use streaming ETL? When there is a need to ingest and process large volumes of real-time data. Now moving on to ELT, a slight variation from a traditional ETL process. This architecture collects data and then loads into a target destination before transformation. By placing the transformation process as the last process in the workflow, there is a reduced latency than the ETL design. A major concern for this design is effect on data quality and violation of data privacy. When data gets loaded without certain transformations which can hide the sensitive data, it may expose the sensitive data. When should we use it? When there is a need to perform a transformations within the target system. Let's move on to the next one, which is called CDC. This design pattern introduces freshness to the data processed using the ETL batch processing. By detecting the changes occurred during the ETL process and sending them to a message queue using CDC, they are made available to downstream processing, which processes them into mini batches, making the data available immediately. When should we use CDC? When there is a need to capture and replicate the real-time changes made to a database. Now let's move on to the last one, which is data streaming process. This pattern is ideal for feeding real-time data to high volume and high performance applications like IoTs and financial applications. Data arrives from a string of devices in continuous streams, gets processed and filtered into records of interests and processed before being sent to various destinations like the dashboards and the real-time applications. When should we use it? When there is a need to analyze the real-time data streams for immediate insights. And that brings us to the end of this session. Thank you for watching. Hi, welcome back to Sigmoid Tech Talk. My name is Uttam. Hope you enjoyed the first couple of sessions. In this session, I will talk about best practices and challenges of a data pipeline. There are several best practices for designing a good data pipeline. I am going to talk about few of them here. The first one, we can call it a modular approach. Break the pipeline into smaller, reusable, easily tested and maintained component. Let's move on to the second one. Use a data pipeline framework. Using a pre-existing data pipeline frameworks such as Apache Nifi or Apache Kafka can simplify the development process. Now let's move on to the third one, which is monitoring and logging. We should always monitor the pipeline for errors and log the data at each stages to to facilitate troubleshooting. The next one is scalable storage solutions. We should always use the scalable storage solutions like a cloud-based data lake or distributed file system which can handle the large amount of data. Use of a data catalog. We should always use the data catalog to store the information about the data such as metadata and lineage to make it easier to understand the data. Now moving on to the next one, which is message queue. Using a message queue can allow you to decouple the different stages of the pipeline, making it more resilient to failures. Use version control for pipeline code and configuration to track the changes and roll back if necessary. Moving on to the next one, which is data validation. Validate the data at each step of the pipeline to ensure that it meets the quality and integrity standards. Data security. Use security measures to protect sensitive data and ensure the compliance with regulations. Now, last but not the least is test and deploy. Test the pipeline thoroughly before deploying it into production and continuously monitor it. Now this brings us to the second part of this session, which is challenges of a data pipeline. There are three major categories that I will talk about when it comes to challenges of a data pipeline. The first one is complexity. In large companies, there could be large number of data pipelines in operation. Managing and understanding all of these pipelines at a scale can be difficult, such as identifying which pipeline is currently in use, how current they are, and what dashboards and reports they are currently serving. In an environment with multiple data pipelines, tasks such as complying with the regulations and migrating to the cloud can become more complicated. Now let's move on to the second factor or second challenge, which is cost. Building a data pipeline at a scale can be costly. Advancements in technology, migrations to the cloud, and demand for more data analysis may all require the data engineers and developers to create new pipelines. Managing multiple data pipelines may lead to increased operational expense as time goes by. Now let's move on to the third one, which is efficiency. Data pipelines may lead to slow query performance depending upon how data is replicated and transferred within an organization. When there are many simultaneous requests at large amount of data, pipeline can become slow, particularly in situations that involve multiple data replicas or use a data virtualization techniques. Now this brings us to the end of third session. Thank you for watching.